Thanks for your patience, everybody. We'll just give people a few more seconds to join here, and then we can get started. Some people are wondering what's running behind me. If you're at AU in Las Vegas, we put DED robots in a shipping container. And that's a video from AU Las Vegas. Zoom just lets us have fancy backgrounds. All right, I think it's taken so long that we should probably get started. Since most of you were expecting to do this in YouTube, I can give you a little bit of an overview on how this whole Zoom thing works. But you should be able to see a chat over on the side in Zoom. Maybe you've started having your kids use Zoom for their classes or something, so maybe you've already got it figured out. But there's chat over on the side. You can use that. I'll keep an eye on it while CJ's walking through some tips and tricks in the manufacturing space. If you've got questions, keep the conversation coming in on the chat. I can interrupt CJ and have him answer some of your questions live. And again, apologize for wasting a few of your minutes at the beginning there trying to get this to stream to YouTube. We'll sort that out for next week.
Yeah, and this is supposed to be a hangout, right? It's not supposed to be me just talking at a bunch of people. I want to be able to converse with you guys. I'm going to make mistakes along the way. This is a part that I've made several times, and I've done it different ways each time. And I just have a couple of things that I can show that make my programming process a little bit easier. Yeah. We good to go, Al?
Yeah, let's go for it.
All right, cool. So when I'm making parts, generally I don't start programming right on the part file itself. I'll put the part into its own CAM design file. That way, any geometry I'm making can stay separate from the discrete part design. So I have the gearbox cover open already, and I'm going to do a derive. And I'm going to derive into a new design, and I'm going to select the top component object and click OK. And this will derive that component into a new document. And it's a component that contains all of the bodies and sketches and whatever other geometry I would have used. So that's really nice if I'm going to create toolpaths that use this geometry. And I'm going to save this as Gearbox CAM. All right, so in the data panel, I have a new document called Gearbox CAM. And the first thing I want to do in this document is do my first setup. And I have some fixtures already set up here as templates. We can go over how to create fixture templates in another hangout later. But I have this JAWS reverse template. And I know I want to use the JAWS in a reversed orientation because the material is about 4 inches wide for this part. And I know that if I have the jaws in the normal orientation, they won't fit. So go ahead and lay that part in there. I get my one free move so I can place it wherever I want and click OK. I'm going to break the link so that I can make some modifications here. And I know I want my stock to be 6 3/4. I want this to be 3 3/4 for Y and 1 1/2 for Z. And
so
one thing
out
I
of curiosity, how many people are using Derive for their manufacturing documents, and how many are using parameters for their manufacturing documents? I'm just curious to see it in the chat.
Yeah, please tell us in chat. And also, there's a few key differences between Derive and insert into current design. I won't go into all the details now. We could do that another time. But for this purpose, if you're going to insert something and then break its link and have all of the feature design history in that document, you want to insert into current design. And in that fixture template, I placed a joint origin in a place that is convenient for me, but it's at the top of the jaw faces. So what I can do is, actually, I made a mistake. Let's roll back really quick. Before we talk about any of that, this part's still floating in space. And so I need to do an as-built joint between the component and the top level of the document and make that rigid. So now the part doesn't move around when I click on it. Okay, so back to where we were. I want to create a joint between this joint origin. And if I hover over this bottom face of the part, I get this centroid origin here. And so I'm going to use that. And this is why that joint origin was convenient for me. I can now say that I want the part to be some distance above the top of those jaws. So this number that I put in here, so I'll put in 200 thou. So now I know that the part is 200 thou above those jaws. Makes it pretty easy. And actually, I want that step feature to be on the front. So I'm going to go back into my joint and turn it around 180 degrees. Just like that. Okay. So now I can continue with my setup and create a manufacturing setup here. And first I'll set the orientation for my work offset. And I've changed the orientation to Z and X, so I can select a Z face to be normal to, an X face to be normal to. And you see that sets my orientation. And I really like using 0-point clamping systems like this Lang work holding system. And what I can do is I can select the bottom center of the fixture to be my work offset origin. And when all this was modeled up, I made sure that I assembled all the components so that the origin was in this position. And so I don't even have to select geometry. I can just select the origin from the assembly itself. For the model, obviously we want that gearbox cover. And for the stock, right now it's set to a relative size. We have the stock modeled, so I can select from solid. And my setup is complete. Did anyone say anything about whether they use derive or any parameters or anything like that?
Yeah, a few people mentioning that they use parameters. A few people saying that they do XREF. So this is good.
Okay, good. Yeah, using assemblies and inserts and XREFs are really good for getting your fixtures into your CAM documents. They're incredibly helpful. I'll show some ways to use fixtures in operations regarding heights and things like that. Okay, so the first thing we want to do is face off the top of the part. Pretty easy. So I'll select the face operation, open up the tool library. I've gathered all the tools that I need beforehand, so I can just pull them out of a library. But that's the face mill I want to use. Okay, it pulls in some default feeds and speeds. I'm just assuming that this is aluminum and it's going to be made on a Haas VF2 SS. So I have 12,000 RPM to work with. In this case, I'm going to use 10,000 RPM and 200 inches per minute, which is something I'm pretty comfortable with. I'll turn on multiple depths. I want to use 50 thou step downs. So it will automatically calculate the number of step downs it needs to take between the stock top and model top. Okay, so we get something like that. And we can make some more changes to this. There's some other settings that I like to modify. So for example, I don't like to have the vertical lead-in radius, so I just set this to 0. For the pass directions,
CJ, what if you never wanted a vertical lead-in radius? What would you do?
Oh, if I never wanted that to have a number, if I always wanted it to be 0, I could right-click and make default. And every time I open up the face operation, this would now just be 0.
Yeah, it's a good tip.
You could also save it as a template. So if you don't want to modify the basic defaults, but you want to call it up later, you can save the whole operation as a template. I'm just going to go ahead and make a default now. For the direction, right now it's doing both ways, right? So it climbs and then conventional cuts all the way across the part. I want it to climb only. So I could set pass direction to climb. Okay, so now we just got those one-way directions. And the last thing I want is for the tool to extend off the end of the stock. And we do have a checkbox for that, extend before retract. And this is how you'll see me set up most of my facing operations, just a combination of those settings. All right, any other comments so far? Anybody making fun of me yet?
Nobody's making fun of you. I think a few people are jealous of your green screen setup.
Oh, well, we just checked early on Amazon. The green screen that I bought is currently unavailable. So
I'm not
sorry.
the only person that had that idea. Yeah.
Yeah.
There was a question about why you did one direction only, and I think some other users answered it, but what's your answer?
So with one direction, specifically climb, uh, the chip forms from the largest thickness to the smallest thickness, and that's generally better for the cutting edges. Um, for indexable tools, it's almost a negligible difference. But if you're taking really high performance cuts, really deep, heavy cuts, high horsepower, changing directions could change forces on the tool. It could break your tool. So uh, for cuts like this, I just like to do one way. It's more of a preference, really.
Yeah, that's good. I think in general, with anything in machining, the more you can create habits so things happen consistently, the better you are to avoid errors too.
Right. And especially, it really depends on your goals. So if you're making one part, maybe you don't care. But if you're making thousands of parts and you're worried about cycle times and things like that, you might choose, you might make decisions based off of whether you need it to be the shortest cycle time or you need it to be a really reliable process and not break any tools. Might be a trade off.
I don't know how deep to dig right now, but the idea was to answer questions live in the sync up. And I see a comment about when you choose climb, there isn't an option to make it work its way outside from the outside to the inside, especially if the width is significantly shorter. Yeah, that's true. You can't do it with the facing operation. You can use the adaptive clearing or a spiral operation as a facing toolpath. Maybe it's worth showing that, CJ.
Yeah. It's kind of an interesting way of doing it. You have to be clever with the heights. So if you select a 3D adaptive toolpath and you set the bottom height to model top, okay, so, and our top height is the stock top, this won't cut down into any geometry, but it will face off the part. And it's not perfectly straight lines, so it is going to have quite a bit of code. Let's see if we can change the color here. Oh, it's still going to be green, but you get the idea. So a 3D adaptive strategy, if you set the bottom height to model top and the top height to stock top, you could get a spiral end result for face toolpaths.
That's good. Thanks for the question. I don't know if that answers your question, but thank you.
Yeah, it's a good question. Okay, so for roughing off the rest of the part here, we've already done the top. I'm going to use 3D adaptive clearing again. And I'm going to use my favorite half-inch end mill. It's the Swift Carb ramp mill. Okay. And this is where I'm going to get clever with some of the heights here. You can see the bottom height right now just defaults to model bottom with an offset of 0. And you can drag and drop the height wherever you want to type in the number. But you can also drive this number from an expression. And here's what I want to do. First, I want to go past the model bottom by at least the corner radius. It's a bullnose end mill, so I want to go past the corner radius of the tool. So I'll say minus tool corner radius. And then for adaptive clearing, the stock to leave parameter, the axial stock to leave parameter, is also applied to the bottom height. So I also want to subtract the vertical stock to leave. And then whatever number I put in next is going to be additional distance from the model bottom. So I'll say minus 5 thousandths. And now this is a parametrically controlled number that is offset from the bottom based on the tool that I select. So if I go ahead and generate this toolpath, we'll change some of the other height settings so that we get a nicer clean toolpath. But you can see now it goes past the model bottom here. And when I look at the result, you can see we go past by at least a corner radius and just a little bit more, which is that 5,000 number that I put in there. Now, if you've set this all up and you're more worried about not hitting the fixture rather than going past the tool corner radius, instead of doing all that, you can say from selection, you could select this top face of the fixture and say, I want to stay off that 50 thousandths. So that was one of the reasons that I said having the fixtures in the model is really advantageous. You just have to make sure it's modeled correctly and that your work offset is in a consistent place, which is why I've placed it on the bottom. Okay, so this isn't the most efficient 3D adaptive strategy, so let's change that. With prismatic parts, 3D adaptive is actually still quite useful, and there's a couple of tricks you can do. So the maximum roughing step down, first of all, 3D adaptive clearing works from the deepest step down that it can, and then works its way back up, and then goes back down another max step down and works its way back up. So what you do is you make the max roughing step down and the fine roughing step up the same number, turn on flat area detection, and you get this really nice, well, let's see what happens. I might get an extra step, because I want to go back and set this to what I had it at before. Okay, so what I was saying is that you're supposed to get this really nice prismatic roughing toolpath. Yeah, just like this. That's really nice. Any other comments coming through that I should?
I'm not seeing too many comments, so I think you can keep going. Of course, feel free to interrupt CJ, though he loves questions.
Yeah, that's what I'm here for. I don't want to just be talking at people. So the other thing about this toolpath is there's lots of retracts and repositionings, and there's a way that we can keep the tool down. On the linking tab, in the linking area here, we have a couple of parameters, and one of them is linking stay down distance. So
you may pause for a second. You do have a question. There's a question. How do you achieve the last toolpath? Somebody thought it was amazing.
Oh, well, I mean, that's what we've been talking about this whole time, right?
Yeah, well, it's so amazing. Go through it a second time, because I think it clicked after they saw the result.
Yeah. So I'll do that start to finish again. Okay, so I've opened up a 3D adaptive toolpath. Here's my 1/2" tool. It's a 3D toolpath, so I don't have to select any geometry. Bottom height. This is where things get interesting. I'll write in that expression again. So I'll say minus tool corner radius minus vertical stock to leave and minus 5 thou. Okay, so that sets our nice bottom height.
And you could set that as a default too, couldn't you?
I could set that as a default. Yeah. And then for the passes, the default optimal load or step over for adaptive clearing is 40% of the tool, which is good for getting a quick calculation, but it's not something you'd really normally do. I like to start with 10% of the tool. So for a 1/2" tool, this is going to result in a 50 thou step over, which is a light step over for aluminum. You can go quick, but if your machine has a lot of torque, you can really power through aluminum. But it makes a nice toolpath. Max roughing step down. So I know that the tool has a flute length of 1 1/4 inch. So I'm going to put in a max step down of 1 240 thousandths. And same for the fine step down. Okay, and then turn on flat area detection. And then I don't have to change any other settings to get that toolpath. They should arrive at what we were at before. Yeah.
And you could have also made the fine step down equal to the large step downs. If you change it, they'd be linked.
Yep, you're right. So I can say, instead of typing in the number, I could type in max step down. And then that is the parameter. So now these are linked. If I type in 1 inch for max, the other one becomes 1 inch as well. So expressions are really handy.
I hope that was helpful for the person that asked.
Yeah. And to get rid of all of those linking moves, first thing I'll do is increase the max stay down distance. So any move that's less than 6 inches will attempt to stay down as long as it's not trying to go through any geometry. There's the stay down clearance. So when it tries to go around something, it will stay at least 100 thou away from any geometry. Stay down distance, this is like a 0 to 100% slider that we've implemented as a combo box. I'm going to put in 80%. And that's all we need to do. So now when I click OK, instead of all of those retract moves, they will be stay down high feed moves. You can already see a bunch of them down here, all those dark yellow moves. And anywhere that it was more efficient to full retract and go over the part, it will. So it's not like it's all or nothing. You get some optimization in there. And let's take a look at the simulation result. So you can see a couple of the areas where the tool is staying down instead of trying to retract. But when it needs to, it does. Cool. I see a comment in here. Thanks. Amazing. So you're welcome. All right, and let's keep going. Okay, so let's rough out these bores now. I'm going to hide the stock so I don't have to keep selecting through it. Okay, so I might need to do these in a couple of steps. There's not one toolpath that can just do them all nicely. So first I'll do this bore here, and I'll do that with 2D bore. I can use that same 1/2" end mill. Select that face. And for the heights, there's not a axial stock to leave setting for 2D bore, but instead you can say I want to stay 5 thou off the whole bottom, and that would have the same effect. Stock to leave, radial stock to leave, 5 thou, that works fine. The pitch of the bore to cut, we'll do 50 thousandths there. And actually, now that I'm looking at this, the hole might be bigger than 1 inch. I didn't actually measure it, so we might run into a little bit of a problem. But if we do the smaller one first, might not be an issue. So let's give it a try. Yeah, there's a little island down there just from the cusp of the corner radius, but it's not an issue. Okay, so there's one 2D bore, and I'm going to use another one to do the remaining 3 holes. So I hit Control D there to duplicate that toolpath. So now it's the same exact toolpath. I can just change the settings. So I'll select the face of those 3 bores, go to whole bottom, and then I could do that that formula I was working on again. I'm feeling a little lazy, so I'm going to just type in minus 85 thousandths. And that should give me what I want. So I'll hit OK on that. And that does the 3 bores. So now the whole part is roughed on op1. Now I'm ready to do some finishing. And first I'll do the silhouette around the outside. And I have another tool that I like to use for finishing. Okay. So I select the edge going around the outside. That works perfectly fine. For the heights, the default selection method for bottom height is from selected contour. And that is the model bottom in this case. So I can say minus 3 thousandths, and then I'll stay 2 thou above that minus 5 thousandths number I used before. Using a lot of memory here to put in numbers that I need, but okay, so we get something like that. And if I was worried about the tolerance of this feature, I could turn on wear compensation. I prefer wear compensation instead of in control. And also, if I'm worried about
so
the
CJ,
witness mark,
why do you prefer wear comp? Maybe explain cutter compensation, and then why do you prefer wear compensation? I'm curious what other people think about wear versus in control.
Okay, so the compensation that is on controls is designed to be either a full radius or full diameter compensation, where you type in the diameter of the tool, and you could write the points as the geometry. So say you had a 1x1 square, you could write in the points 0, 0, 1, 0, 1, 1, and so on. And if you put in the diameter of the tool, it will calculate the offset that the tool needs to be at in order to cut that geometry. So the problem with using full diameter or full radius comp is that sometimes you can create lead-in dilemmas where some moves can't fit the full radius or diameter of the tool based on the comp and things like that. So instead of using a full number like a 1/2 inch, use wear compensation, which is you put in a number like 5 thousandths. And then suddenly the code can be a bit cleaner. It looks like it's uncompensated code. And what I mean by that is the tool path will look like it's been offset for the proper diameter of the tool. But you can adjust by a few thousandths rather than having to type in the full nominal diameter.
That makes sense. And for people that don't understand wear compensation at all, it's really a way of saying you're going to program assuming your tool is 1/2 inch, but when you get to the machine, maybe the tool is 495 thou. So you shouldn't have to go back to the CAM system and change the tool diameter. You can adjust it on the control.
Right.
Wear says I'm cutting undersized by 5 thou. The tool, the full tool would say the tool is 495 instead of 500 thou.
Right.
I hope that's helpful, or if the distraction's not helpful, again, let us know in the chat. The point of this is supposed to be a conversation, so feel free to keep asking questions.
Yeah. Now, the entry position's on the right side of the part over here. I'd rather have it be on the front. That way when I'm setting this thing up, I can watch the tool as it comes down. So in the linking tab, I'll set the entry position to be this edge here, and I get a little white dot, and it will get as close to that point as possible. So you don't even necessarily have to select something that's on the contour. You could select something that's anywhere on the part, and the entry position will just be as close as it can be on the contour. Okay, so I've got my position there. And also to mitigate the witness mark of the tool on the part, I can add a finishing overlap. So this finishing overlap will extend the pass a little bit further past where it entered. And I like to make the lead-in radius a little bit bigger. So instead of 10% of the tool diameter, make it 20. And this just helps the tool roll onto the part a little bit better.
So you've got some other questions, which I think are great questions. People don't always understand entry point. Think of it like a guidance point. It's going to try and get as close to that point as it can without creating a tool path that gouges. There is a separate option that's a pre-drill location, and a pre-drill location, it forces the tool to enter at that point. But when you're using entry point, it's really just saying, try and enter as close to here, but still give me a good tool path.
So let me demonstrate that. If I set the entry, right now the entry position is on the contour. If I select an entry position that is not on the contour, for example, up here, that's not on the contour that I selected at all.
Your head's right in the way of the linking parameters, though.
Let's move me over here.
Where'd he go? CJ's gone.
Yeah, it's this guy right here. So I can just select any point and it will get as close to that point as possible. In this case, it happened to be on the back of the part there.
I hope that's helpful. That was a good question.
Okay. Now we need to finish these faces up here. And this is probably my favorite part of the demo because this is a really powerful thing to do in 2D contour. So select 2D contour. We'll start with this edge down here. So I've selected that contour. And if I just hit OK right now, I get my single pass there, which is okay. But I want to finish that entire face, and I want to have a 5 thou finishing pass on that wall. That's not what I wanted to do. So first I'll go to the passes tab and I'll turn on roughing passes. And it doesn't actually matter how many passes I put in here yet, because we're going to trim them. So if I put in 10, it will give me something that looks like this. Okay, so we're getting closer. And then the default finishing step over is 50 thousandths in this case. So I need to go back and change that. Okay, step over there's going to be 5 thou. Now if I go over to geometry and turn on stock contours, if I have no selection, it defaults to the bounding box of the stock that we created in the setup. But I can just select this one face here, or this edge, And now the stock boundary is limited to that face, and the toolpath gets trimmed to that area. I think this is an awesome setting to use. Yeah. So I can do the same thing for the top face. So if I duplicate that toolpath, select that guy there.
I leave you may have been good to just for a moment show that the default was the stock, so it would have trimmed to the stock boundary if you hadn't selected anything.
Right. Yeah. If
so you see that orange preview, it would have gone out to the bounding of the stock, or you can select a chain to trim the toolpath too.
Right. So just again, if I turn off stock contours, this is the default result. If I turn that contour back on, this is the new result.
And then you'll notice it's extending past, so it's never plunging into stock. It plunges in there and then leads on. The stock setting will actually extend a toolpath as well. I don't know if there's a good feature on this part to show that. Actually, that lower contour would if you set it to stock.
So if I unselect this, you'll see those passes get extended.
So it's a pretty powerful little feature. There's some questions for you, CJ, in terms of setting defaults for checkboxes. In this case, it was the defaults for wear compensation. Can you just show how to do that and compare and edit?
Yes. So there is a hidden menu. If you right click and go to compare and edit, this is a grid list of all of the parameters for all the toolpaths that you select for compare and edit. So you can select more than one toolpath and access this
Maybe
window.
You should, just to show a couple more tricks. It's a bit of a tangent, but again, we were hoping for tangents.
Yeah. So I can select those three toolpaths, those three 2D contours, compare and edit. And now I'm modifying all of the parameters for all of those operations at once.
You can even show how you can see which ones are different, for example.
Yeah, this little combo box down here, I can say, just show me the parameters that are different. Or non-default. So these are all the parameters that I've modified from their default. And what was the one that we wanted to
we wanted to do wear compensation or cutter compensation.
Okay, so compensation. So compensation type. The first one we used wear compensation. The next two we haven't changed from their defaults. So I can set them all to wear. And if I want this to be the default for one of those operations or for an operation type, I can right click and now I can say make default. So for anything that isn't a text box, so if it's a checkbox, a combo box, what else do we have? I think that's it. Just combo boxes and checkboxes. Yeah. You can make default. And also, oddly enough, you can write an expression that will determine which one to use. I haven't actually tried. I haven't written any myself, but I've seen a few.
Hopefully that answered your question. I know it was answered in the chat too, but for the purpose of the video, and I think seeing it is super helpful. So again, thanks for the folks that are asking questions.
Yes, much appreciated. Okay, so we've done some finishing. Now we just need to finish those bores.
So there is a good question, and I think it's a healthy debate to ask. Why use 3D toolpaths versus 2D toolpaths? And this hits on a common misunderstanding of the toolpaths. The 3D toolpaths are solid driven. They're driven off of the 3D solid, of course. They can be used for prismatic parts like is used here, but generally speaking, you have less control over exactly how the toolpath performs. The 2D toolpaths require, generally speaking, they require explicit selections and they give you more control over the toolpath. So if you're trying to automate the process and program it faster, you could have used a horizontal toolpath to finish things, but you wouldn't have got as optimized a toolpath or as nice of a finish of tool marks on your part, whereas the 2D method is going to give you more control. But I think CJ's demonstrated a good job here how you can use 3D toolpaths for prismatic parts. But then sometimes there are use cases where you're better off using a 2D toolpath because it just gives you more control over the quality or the finished result of your toolpath.
Yep. Also, a couple little optimization tricks. The defaults for a lot of operations are meant to be safe, not necessarily fast. So all of these operations right now, you can see have plunge feed rates from the feed height down. So let's change a couple of things here. I've selected all of those. I'm going to compare and edit. And I'm going to look for first the feed height. And I'm just going to disable it. So now it'll wrap it down to the first position on each one. For the retract height, we've already faced away everything from the top of the stock. So I'm just going to say from model top, let's do 100 thousandths. Okay. And the clearance height is relative to the retract height. Right now it's 400 thou away from the retract height. I'm just going to set that to 0. So that's what the toolpaths look like right now. Let's look at what they turn into when I regenerate these toolpaths. Okay, so now we don't see any of those red lines, which were the plunge feed moves. So now they all wrap it to their position. And those retract positions are also much closer to the part. So there's some nice ways that you can optimize toolpaths through compare and edit all at once.
We should probably be mindful of time. So let's kind of speed through the second half of the part, or maybe even open up your finished part so you can show. I think the NC programs and setup sheet stuff was pretty useful. So maybe.
Yeah, so I'll go ahead and jump over to my my finished one.
I know you had planned to do both sides of the part, but I think it's going to make more sense just based on the few minutes that we lost at the beginning.
Let me just a second here. Hide some stuff real quick.
And then while you're doing that, there's a question in the different colors of the toolpath. Yeah, you're going to get some colors that are entry and exit moves, and those are the red ones. You're going to have some yellow toolpaths that are linking moves. So that's repositioning. The entry and exit moves should not be in stock, whereas the entry and the repositioning moves may be in stock. And then the blue moves are the cutting moves. Did I miss any colors, CJ?
I wasn't listening.
I was talking through the different colors of toolpaths.
Yeah. Okay, so this is the finished one.
One other question here, which I think is a great question. So while you're doing that, the question is, can you use multiple diameter offsets for one tool? It's a little bit of a hack, but you'd have to have the tool in your tool library 3 times. Call it tool 1 every time, but have a different diameter offset for each of the times. I understand it's a hack, but it's going to solve your problem.
I want to talk about that more. Not on this particular live stream, but we should figure out a way to solve that. It's been coming up.
CJ is a product manager responsible for the tool library, so he's the right person to have that conversation with.
Okay, so some of the things that are different in here is I spent a lot of time going through here and designing the second set of soft jaws. So Fusion, being a parametric modeling system, is really great at being able to assemble and model fixtures. And one of the clever bits that I added in here is one parameter is the jaw spacing. So when you're setting up soft jaws, you need to clamp down on like parallels or something of a known thickness. And so in this case, I could say, well, I'm clamping on 1/4 inch worth of parallels. And that updates, maybe that wasn't obvious. Let's make it 1/2 inch. Right, so the model for the soft jaws parametrically updates based on the width of the jaws there. Set it back to 1/8. Okay, recenters itself there. And the reason I spent so much time modeling this is because I wanted to take the pressure off of all of these bosses here. Every time you add a contact point on a part that you're gripping in soft jaws, you could be distorting the part, especially on internal fillets. So a fillet like this, I don't know if I could turn off the fillet and demonstrate it, but all these internal fillets become pinch points. So it's good to relieve the pressure off of those pinch points. Anyway, with all of that stuff programmed, do a little regeneration here. You are able to simulate both. Almost done calculating.
As a user that wants your parametric design for SoftJazz, maybe we can just get it in CAM samples for them.
Oh, yeah. We can do that. Okay, so while we're waiting for that to calculate, what I want to show here is the new NC programs function. So before, you could select both setups like this, hit post process, still being generated. And you would be able to post two setups at once, and it would interweave the operations if you so chose.
I'll do a little plug. It's still being generated because every time the model changes, we have to interrogate and make sure nothing happens. So we recalculate the toolpath. Keep an eye out for some feature flags, some previews in the near future. And maybe CJ, can you just show them how to get at the preview functionality? Because I think it's important.
Yeah.
If you go to preferences, you'll have an option to get access to functionality that's not fully released yet.
Hold on, I did that really quick. Let me, the preferences option is right here when you click on your name.
Yep. Don't actually show them because you have more access to more than others. But all I'm saying is keep an eye out for those preferences. In the near term, we're going to be releasing some functionality that makes the model go dirty far less. And for anybody that uses the product a lot, that's pretty important.
Yeah.
Did I buy you enough time?
Yeah, I think so. So now we can look at the Sensi program, and really what this is you're storing all of the settings for post-processing and which operations you want to include in a program so that you can recall it later. And what we've done is you can say, well, I want to include all the operations from setup 1 and setup 2, and you can simulate them, right? So when I right-click and simulate a setup, everything goes. And also, what you're looking at here is the list of operations that in the order that they'll be posted in. So this checkbox, reorder to minimize tool changes, you can see some of the operations rearrange themselves. And what's happening is it's looking at tools that I'm using between the operations, shared tools, and wherever it can, it will switch between the two setups to minimize the number of tool changes without breaking setup order. So setup 1 will be executed in the order that it is in. Setup 2 will be executed in its order, but it will interweave the setup so that the number of tool changes is minimized.
So the use case would be you're running a dozen of these parts, and the top side you're doing on G54 on one vise, and the bottom side you're doing on G55 on another vise, and you run them together. And we nest the two setups together so that you do your facing operation on both of them and then do the tool change. It's a pretty powerful way to save some time.
Yes. Cool. So we're running a little bit over time.
Yeah.
Even though we didn't really get to everything that we wanted to. But that leaves lots of opportunity to talk about more things later.
Do you want to show setup sheets quickly?
Oh, yeah.
We'll end with that, and then while we're wrapping up for next week, we'll get YouTube working properly. I promise. Yeah. We tested things before we got going, and then when we went to do it live, obviously there were some issues. So thanks for being patient with us. But interested in what you'd like to see next week.
So to create a setup sheet using the new setup sheet workflow, if you right-click on NC program and generate a setup sheet from the NC program, you get the Fusion Save dialog. And what this is doing is saving the new setup sheet to Fusion Team. And it's this great new interactive setup sheet. Still working on it, so there's some things that'll be changing. But you get a picture of the part, you get the tool list. These dialog or these panels are collapsible. And the option that we're not showing here yet is we'll have a drop down for customizable setup sheets. So you can show, hide, rearrange everything that you see in here to your liking. And this is stored on Fusion Team. So I can open this guy up, opens in a browser. So now if you post a setup sheet to Fusion Team, guys on the shop floor can open up on their PC or tablet or whatever they have this file. And it shows the Fusion design file that it's used in. And I can preview the setup sheet from here. This does currently have the drop down for showing the different tool types. So I can do tools only, or I can do a compact version of the setup sheet. I think we have one with no images. Yeah, so this one just has the summary images and just parameters. And you'll eventually be able to customize these and make your own.
And it's not shared right now, but if they wanted to share it with an operator, how would they do that?
Well, if the operator is part of their team, they'll just be able to log in. But if you want to share it publicly, there's a share link. Right? So if you're observant and write that down, you could go view that now.
Or just copy and paste it into the chat.
Where is chat? There it is. Oop, that didn't work. Here we go. Yeah, so now anybody should be able to go view that setup sheet.
I see a few questions on tool libraries. There's a couple questions throughout today on tool libraries. Maybe we should do a deeper dive on tools and tool libraries next week.
Yeah. Sounds good to me.
Well, hopefully this was helpful. Again, our apologies for not being streaming pros yet at making Zoom and YouTube work together. Appreciate your patience, and especially for the folks that joined in the conversation with the chat, that made things go a lot better.
Awesome. Thanks, everyone.
Have a great weekend.